the group 4 and our topic is all about X-ray tube. My name is Jenny,
Yula, Kaisin,
Filito,
Pearly, Lex,
Aaron.
and this is group 4. The X-ray tube is a crucial part of the X-ray imaging system.
Often overlooked by radiologic technologies.
It consists of two primary parts, the cathode and anode, which are electrodes.
The tube's external structure includes support system, protective housing, and enclosure.
While the internal structure consists of the anode and the cathode. Proper use can extend tube lifespan.
While CT and interventional radiology use structures.
The three external components of the X-ray tube are the support system, protective housing, and metal or glass enclosure. In the support system, we have three types, and that are ceiling, floor-to-ceiling, and C-arm support system. The X-ray tube and housing assembly are quite heavy. Therefore, they require a support mechanism or system so that the radiologic technologies can position them. Let's proceed to the second external component. We have protective housing. The protective housing of the X-ray tubes is designed to prevent accidental electric shock, mechanical support, and damage from rough handling. The last one we have is glass or metal enclosure. Glass or metal enclosure of the X-ray tube refers to a large electronic vacuum tube with two electrodes containing a Pyrex glass enclosure.
The two primary parts of internal components are cathode and anode. Cathode refers to the negative side of the X-ray tube, and it has primary parts, a filament and a focusing cup. Dual filaments of thoriated tungsten are used in the cathode. When heated, these filaments emit electrons via thermionic emission, which causes electrons to boil. The cathode filaments are contained under a metal shroud known as the focusing cup. The purpose of cathode in an X-ray tube plays a vital role in generating and controlling the flow of electrons, which are then directed toward the anode to produce X-rays used in medical imaging and various other applications.
Anodes in X-ray tubes come in two main types, stationary and rotating. The rotating anode X-ray tubes offer an advantage over its stationary counterpart. It allows the electron beam to interact with a much larger target area. This increased target area enables a higher tube currents and a shorter exposure times, enhancing the efficiency of X-ray production. Stationary anode X-ray tubes are used in a dental X-ray and other portable imaging systems in which a high tube current and the power are not required. Now let's focus on the choice of target material. Tungsten is the material of choice for general radiography in X-ray tubes. It offers several key benefits. First, tungsten has a high atomic number, which is 74, resulting in an efficient X-ray production and the generation of high-energy X-ray. Next, tungsten also exhibits excellent thermal conductivity, similarly to copper. This makes it efficient to dissipating the heat produced during X-ray production, preventing damage to the anode. Lastly, tungsten has a high melting point. These characteristics allows tungsten to withstand high tube currents without pitting or bubbling, ensuring the longevity of the anode.
Focal spots are source of emitted X-rays with smaller ones, resulting in better image clarity, but potentially overheating. The line focus principles maintains a small focal spots, while more heating effective focal spots are determined by the target angles and can be influenced by different angle standard sizes. Low focus radiation caused by electrons bouncing off the focal spots can be addressed through the geometric designs and metal enclosures. Understanding focal spot, effective focal spots, and the Hill effect is vital in radiology to ensure clear image and minimize patient exposure to radiation. Proper equipments and positionings are essential for quality imaging.
The first reason for X-ray tube failure is the rapid generation of heat during X-ray. On this process, when the heat is excessive during a single exposure, before the X-ray is used, it is in a normal temperature. When suddenly an activation of the X-ray, the sudden acceleration and excessive heat from natural state breaks the anode, making the X-ray tube useless. The second reason for X-ray failure is the continuous elevated heat that the anode is exposed to. The anode experiences extreme heat on a prolonged period, making the anode and its part, the rotor, the oil bath, the X-ray tube housing, the bearing, and the glass enclosure to crack and fail.
By using X-ray properly, it can provide longer years of service. With inconsiderate use, its life may be shortened. A final cause of tube failure involves the filament. This tungsten is vaporized slowly because of the high temperature of the filament. This tungsten, together with that evaporated from the anode, may disturb the electric balance of the X-ray tube, causing sudden intermittent variations in tube current, which frequently result in sparking and tube failure. The most common reason for sudden tube failure is electron sparking from the filament to the enclosure because of tungsten that has been vaporized.
Rating charts are used by Radtech as guides in the proper use of X-ray. Its three types are the radiographic rating chart, the anode cooling chart, and the housing cooling chart. The radiographic rating chart teaches Radtech safe techniques to conduct the X-ray tube operation. X-axis represents time, Y-axis is kVp, the curve is MA. Any combination of time and kVp below the desired MA curve is safe, while combinations above it are unsafe. Enclosed with X-ray tubes are a series of radiographic rating charts depending on its filament in use, node rotation speed, the target angle, and its voltage rectification. Anode cooling chart, the time required for a heated anode to cool. Thermal energies unit are heat units or joules. Housing cooling charts. Shape and use is similar to anode cooling chart, wherein maximum heat capacities is in the range of several million heat units and complete cooling takes 1 to 2 hours.
1, 2, 3. And this is you 4. Legs. Go. Hi everyone.
X-ray tubes. Okay.
In radiology,
In